Day 432 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3439, reschedule meetings for maximum free time 1. The difficulty level is medium, but you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, and subscribe, and don't forget to share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given an integer event time denoting the duration of an event where the event occurs from time t equals 0 to time t equals event time. You are also given two integer arrays, start time and end time, each of length n. These represent the start and end time of n non-overlapping meetings where the ith meeting occurs during the time start time of I and end time of I. You can reschedule at most k meetings by moving their start time while maintaining the same duration to maximize the longest continuous period of free time during the event. The relative order of all the meetings should stay the same and they should remain non-overlapping. Return the maximum amount of free time possible after rearranging the meetings. Note that the meeting cannot be rescheduled to a time outside of the event. All right, y'all, so that can seem a little bit confusing at first, so let's go ahead and take a look at these examples just to make sure that we're doing this problem correctly. So in example 1, we have our event time equals 5, k equals 1, start time is an array of integers 1 and 3, end time is an array of integers 2 and 5, the output is 2. Let's look at the explanation so we can see how they got this output of 2. Explanation says reschedule the meeting at 1 and 2 to 2 to 3, leaving no meeting duration, leaving no meetings during the time 0 and 2. All right, so let's break this down one step further, y'all, right? So first we have our event time, which equals 5. So this whole linear graph, right, from 0 to 5, that's our whole event. Then within this event from 0 to 5, we have meetings. We have one meeting here from 1 to 2, and we have a meeting here from 3 to 5. These meetings are represented right here at start time and end time. So the start time for the first meeting, it starts at 1, ends at 2 over here. They're both at index 0. So the indexes correspond with each other, right? It says start time of I and end time of I, right? The meeting occurs during the time start time of I and end time of I. So start time index 0, it starts at 1. That means end time index 0, it ends at 2, and that's why we have this meeting right here from 1 to 2. Similarly, with start times, this meeting starts at 3. The end time, the meeting starts at 5, both at index 1. So that corresponds to this meeting right here that starts at 3 and ends at 5. So that's important to remember. These indexes correspond with the start and end time. It's not like yesterday's problem, if you were following yesterday's problem, where the start time and end time was in the same array. This time the start time and end time are in two different arrays, but the corresponding index is the start time and the end time. So once again, index 0 starts, that's the start time, index 0, that's the end time for the same meeting. Index 1, that's the start time for one meeting, and index 1 and end time, that's the start time, or that's the end time for that same meeting. Once again, we have 3 and 5 that corresponds to this meeting right here, and we have 1 and 2 that corresponds to this meeting right here. Now let's see how they got the output. So with the output, they changed the meeting that was at 1 and 2 right here, that was at 1 and 2 to 2 and 3. So that's this meeting, 1 and 2. They took this meeting and scheduled it to 2 and 3. So just imagine we take this, as I'm sure y'all are can guess by now, we're going to be using a sliding window to solve this problem. But imagine we just take this window of time right here, this green window of time from 1 to 2, and we slide it all down. We slide it on down to 2 and 3. So now this green meeting is right here from 2 to 3, and this would be free time. And then we would have free time from 0 to 2. Boom. So I hope that makes sense. Let me just see if I could see how I could give y'all a visual representation of this. So right now we have a meeting right here. Boom, say that's our meeting. And then we have a meeting from 3 to 4. So say we have a meeting like right here. Boom, 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 boom. Or 3 to 5, excuse me. We just take this meeting right here in between 1 and 2. And we push it. Sorry, y'all. We take this meeting right here between 1 and 2. And we're going to push it down between 2 and 3. So let me just delete that. And then we're going to put it right here. Boom. So now we have the meeting at 2 and 3. This would still be here. It would, so that's all we did. We just moved this from 1 to 2 to 2 to 3. And now we have free time from 0 to 1 and 1 to 2, right? So I hope that makes sense to y'all, just in case it didn't. And then, yeah, from 0 to 2, that's 2 hours. That's the maximum free time. But just in case that didn't make sense to y'all, let's look at example 2. Example 2 is the same principle, but we have more meetings, more time. So let's get to it. So in example 2, our event time equals 10, K equals 1. Also, this K, remember this K means we can only reschedule at most K meetings. So we can only reschedule one meeting at this in example 1, similar in example 2. So example 2, we have event time equals 10, K equals 1, start time equals an array of integers 0, 2, and 9, end time equals an array of integers 1, 4, and 10. The output is 6. Explanation says we reschedule the meetings 2 to 4 to 1 to 3, leaving no meetings from 3 to 9. So similarly in this problem to the first example, we're taking this window of time right here from 2 to 3 and we're moving it down right here. So now it's from 2 to 4, and then we're moving it down to 1 and 3. So we're going from 2 to 4 to 1 to 3. That's this gold window right here. So imagine this gold window just slides down to 1, and now it goes from 1 to 3. So after we reschedule this gold meeting and it goes from 1 to 3, now we have 6 hours of free time because we started 3, and then from 3 to 9 we have all free time, right? Leaving no meetings between the time 3 to 9. So it goes, this meeting will end at 3 because we slid it down. Then it go 1, 2, 3, 4, 5, 6. That's 6 hours of free time, and that's why our output is 6, y'all. So I hope that's making sense to y'all. Just remember this event time. This is just from the whole event. Then we have meetings within the event. K is how many meetings we're allowed to reschedule. In this case, we're rescheduling this gold meeting right here, this window of time right here. That's our one meeting. And then these indexes correspond to the start and end time. So 0 to 1, that's the first meeting. 2 to 4, that's the second meeting. And 9 to 10 is the third meeting. We're going to reschedule this 2 to 4 meeting and make it 1 to 3, still 2 hours long. We have to keep the same amount of time for the meeting, but we're just moving it to 1 to 3. And after we move it to 1 to 3, we'll have 6 hours of free time, and that's what we want. We want to reschedule our meetings for the maximum amount of free time. So let's go ahead and take a look at example 3 where there are no meetings to move and our output is 0. So in example 3, we have the input event time equals 5, K equals 2, start time equals an array of integers 0, 1, 2, 3, and 4, end time equals an array of integers 1, 2, 3, 4, and 5. So the output is 0. Explanation says there is no time during the event to that's not occupied by meetings. So as you can see, right, start time, we have a meeting from first let's look at the event time. Our event time ends at 5. So we have from 0 to 5, we have meetings in between that time. We could say from noon to 5. Let's just say from noon to 5 we have meetings. And in this case we have a meeting every hour from noon to 5 or 0 to 5, right? So from 0 to 1 we have a meeting. So we boom. Then from 1 to 2 we have a meeting. So there's no space to slide. There's no space to move this window down, or like if we're looking at this example, there's no space to move any window so far because one meeting ends or starts at 0, ends at 1. Then the next meeting starts right away at 1 and goes to 2, right? Then we go from another meeting from this ends at 2. So then we got another meeting after that that starts at 2. Boom. And that ends at 3. So we got a meeting from 0 to 1. We have a meeting from 1 to 2. And we have a meeting from 2 to 3. Then we have a meeting right here from 3 to 4, right? So now we have a meeting from 0 to 1. We have a meeting from 1 to 2. We have a meeting from 2 to 3. And we have a meeting from 3 to 4. And finally, we have a meeting from 4 to 5. So really we have a meeting from 0 to 1, then we have a meeting from 1 to 2, then we have a meeting from 2 to 3, then 3 to 4, then 4 to 5, and 5 is our end time. That's our event time, right? So there would be no space in between any of these meetings to reschedule or open up free time. So since there's no space for us to move our or reschedule our meetings, our output is 0. So I know that's a lot to take in, y'all. I try my best to make it make sense. I hope it makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Y'all, solution is not that difficult. We should get through it fairly easily. So let's get started. First thing we're going to do is we're going to create an array to store our free time between events. So for that, we just come right here, declare a variable, call it R, and we'll set that equal to an array. Open up the parentheses, it'll be repeating, colon, 0, comma, count, colon, n plus 1, just like that. Now we need free time before the first event, or we're just going to initialize some free time before the first event. So for that, we're going to say R square bracket 0. We're going to set that equal to start time. Start time, square bracket 0. Boom. Then we need free time after the last event. So we're going to declare another variable, or we're going to say R. No variable. We're not declaring a variable. Sorry about that. But I did forget one part. We're going to come right here, and we need to say, get the total number of events. So we can say let n equal start time dot count. Boom. That's going to get us the total number of events or meetings. Boom. Then we come right here and we say R square bracket n. We're going to set that equal to event time minus end time square bracket n minus 1. Just like that. Now we need a variable to track the maximum free time that we have found. So we could declare a variable and set that equal to 0. Remember, there's no variable for these two. Then we're going to come right here, declare another variable, which is going to get the current running sum of selected free times. So we're going to declare a variable called sum, set that equal to R square bracket 0. Then we're going to need to count the current selected free times. So for that, we come right here, declare a variable called count, and we can set that equal to 1 to start. Now we need to loop through all gaps between events. So we're going to say for I in 1 dot less than n. We're going to open up the brackets and free time between the end of the previous event and start of the current event. We're going to say R square bracket I equals start time square bracket I minus end time square bracket I minus 1. Just like that. Now come underneath this and we're going to say if count is less than or equal to k, we're going to open up the brackets, and if we haven't selected k plus 1 gaps yet, we're going to add the current one. So we're going to say sum plus equals R square bracket I. Then we're going to come underneath that, we're going to say count plus equals 1. Then we come right here, we're going to say else. And now we're going to slide the window and add the current gap and remove the I minus k minus 1 gap from the sum. So to that, we're going to say sum plus equals R square bracket I, come outside the square bracket, minus R square bracket I minus k minus 1, just like that. Now we need to update the answer if we found a better sum. So for that, we come underneath this else and we say ands equals max, open up the parentheses, ands, comma, sum, and this is going to get us the maximum value, whichever one is larger, ands or sum. Now we need to consider including the free time after the last event as well and adjust the sum by potentially removing the oldest gap if needed. So to do that, we come underneath right here and we say ands equals max, open up the parentheses, ands, comma, sum, plus r, square bracket n, come outside the square bracket, minus, open up the parentheses. So then we're going to say n is greater than k. If that is true, if that is still inside the parentheses, if that is true, we're going to say question mark to check if it's true. And if it is, we're going to return r, square bracket n minus k minus 1. And if it's not true, we're going to say colon. We're just going to return 0. Then we come underneath this and we can say return ands, and that should return our final answer, y'all. So let's go ahead and give it a run. Make sure it runs properly before we submit it. Okay, we got an error. Let's see. Cannot find some T in scope. Let's remove that T and run it again. Let's see, and it's accepted, y'all. That's what I'm talking about. Let's go ahead and submit this. Make sure it's still accepted after we submit it. Let's see, and it's accepted, y'all. 0 milliseconds beats 100% of users. That's what I'm talking about. Those are the numbers that we all love to see. So with that being said, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. We'll see y'all then.